All right, ladies and gentlemen. So I'm out, and you might be having trouble with the worksheets. That's what this video is all about. There's two worksheets that you're supposed to do in addition to the lab, and that would be this, which is page 19, which continues on to page 20, which is a blank page. We already did 21, and then lastly, page 22. So I just wanted to go through it a little bit, give you a little help, okay? And just a side note for the lab, that page 18, see how there's this one graph? On this one, you're going to have 3 lines on this graph, okay? And for this one, velocity, you're going to have 4 lines on that graph. Remember, use the strategy from video number 9. Okay, so anyway, let's move on to the worksheets for now. So let's take a look at the first one, free fall graphing, okay? Now, first off, you'll see there are some tips down here, okay? One tip for acceleration, one for speed and velocity, and one for distance, okay? So let's look at part 1. Here we go. Now, when an object is dropped, it accelerates downward at a rate of 9.8 meters per second. But for this activity, let's round that to 10. We're just going to make it nice and easy. Let's round it to 10. And now we're going to complete the chart describing the first 10 seconds. Now, here's the key. In other words, this is every second. It goes from 0 seconds right when you drop something to 1 second later, 2 seconds later, all the way down to 10 seconds into free fall. In other words, what we're doing is we're saying, what is the acceleration at each second? What is its speed or velocity? What is its velocity? How fast is it going at each second? And how far has it moved? How far has it gone down? How far has it fallen each second? So let's just think about that. We already know that acceleration is going to be the same because it's always 10. We said that, and we're never doing anything more complicated than that. We also know that the speed and velocity, well, wait, it's falling. And the whole point is that you get faster and faster as you go down, so that's going to be increasing. So let's see. Oh, maybe I can even do. Oh, that's not going to work. Oh well. So we know that this is going to keep going up. The acceleration is going to stay the same. The speed is going to keep going up, and the distance is going to go up, and it's going to go up more and more each time. Okay. So let's talk about this. All right. In fact, oh look, the tips. They're there to help you. Acceleration will always be 10 meters per second squared. So I can actually write 10 meters per second squared in each and every one. Okay, I'm not going to do the rest. You got to do that. It's always accelerating at that rate, okay? Bottom line, that's how gravity works. Now, as far as the speed, well, how fast is it going right when you just release it? Essentially, it's 0 meters per second, right? But how can we find the velocity 1 second later? Well, we know the acceleration is 10 meters per second per second. So we know that it's getting 10 meters per second faster every second, which means this would now be 10 meters per second, right? The acceleration is 10 meters per second, so 1 second later it's 10 meters per second faster. Then 2 seconds after after 0, so 1 more second later, it's now 10 meters per second higher. It's 20 meters per second. Okay? Now, and that just keeps going all the way down. Now the distance. We have to use this equation here. D equals 1/2 AT squared. That's the one that we have to use. All right, that's going to help us out. 1/2 AT squared. That equation right there, in fact, let me zoom in on it. That equation right there, keep messing up, there you go. That tells us the relationship between how fast it's accelerating, that's the A, and how long it's been doing that, the relationship with those two numbers and how far it is moved. So if we know how fast it accelerates and how long it's been doing that, then we know how far it's moved. That's it. So here's what we do. I'll do 2 as an example, okay? I'll do the first 3 as an example. So the distance is 1/2 AT squared. So for the first one, we would do 1/2, and what's A? What's the acceleration? Oh, it's 10. Okay. What's time? Time is 0. So that's times 0, and 0 is squared. And, all right, cool. What is that? Okay, 1/2 of 10 is 5, and 0 squared is 0. What's 5 times 0? 0. So we know it's 0 meters. Hasn't moved. Right when you drop it, hasn't moved. Okay. Let's try the next one. Now we're talking about 1 second later. We look at our watch, it's 1 second later. We do the same thing. 1/2 times the acceleration, which was 10. And then we multiply that by the square of time. Well, what was time here? Time was 1. And what is 1 squared? All right, let's work this out. Please excuse my dear Aunt Sally. The 1 squared is first. What's 1 squared? 1 times 1? 1. What's 1 times 10? 10. What's half of 10? 5. It's moved 5 meters. All right, and this one, some of you might be thinking, wait, it's going to be 10. It's going to be 10 meters next. You'd be wrong. Let me show you. So 1/2 of the acceleration, which is 10, times the square of time. So time in this case is 2 seconds. We're 2 seconds later. So what is 2 squared? Well, 2 squared is 4. So we would have 4 times 10, which is 40. What is half of that? Oh, that's 20. 20 meters. And that makes sense because you're starting at 0. You get a little bit faster. You move 5 meters. But then the next second, you're moving much faster. So you cover 15 meters. So you get to 20 meters at that point. And so what I'm going to let you do is finish the rest of this on your own. But that is how you do it. Okay? Now, the second part of this is important. It says, on the next piece of paper, make the following graphs using the data above. Acceleration versus time, speed and velocity versus time, and distance versus time. I really shouldn't have to explain this to you at all, but you want to fit 3 separate graphs on this page. Okay? The distance one is going to need the most space, so I would use the top half for your distance one and split the bottom half for your acceleration and your velocity one. I think that's going to help you out the most. Okay? Top half for distance, the bottom half for both the acceleration and the velocity graph. Okay? That's it for the first one. Okay? Let's move down to this one, page 22, the motion graphing exercise. All right? Now, here's the deal with this one. Basically, you've got number 1 is one type of motion. Okay, it's talking about somebody on a football team, your favorite kick returner, I don't know, is on his way to the end zone with no defenders in front of him. He's traveling at a constant speed of 5 meters per second. And so you're going to graph the 3 types of graphs. You're going to do a distance graph for him, a velocity graph, and an acceleration graph for him. Okay. And that's with a constant speed of 5 meters per second. And you actually have to have a little bit of your scales in there, if you can. All right. Let me show you what I mean. Now, number 2, we're talking about acceleration. All right. Now, I'm going to try to do this one here. Well, maybe not. I thought my little notepad was going to work, but it's not working today. So let me just zoom in. Okay. Now, my father and I, we go down a racetrack, and we race his MGB versus my Mustang, if only I still had it. And after accelerating from 0 to 60 kilometers per hour, we found that we calculated it, my dad's average acceleration in the MGB was 10 kilometers per hour per second. That means it's getting faster by 10 kilometers per hour every second. While my acceleration was 12. I got faster by 12 kilometers per hour per second. Okay, so easy thing to do here is, well, start with acceleration. Does it have an acceleration? Well, yeah, it told me. Let's use the MGB. It told me the acceleration was 10. So I just need to do a graph, acceleration versus time, a graph with the flat straight line at 10. Like that. So kind of looks like that. Okay. But what about my velocity? Well, the MGB went from 0 to 60. So you have 0 to 60 kilometers per hour on the Y, time on the X. And if it's going up by 10 every second, you would go 0 to 10 to 20 to 30 to 40 to 50 to 60. And so it should be a diagonal line going up by 10 every 1 second you go over. And then for the distance one, well, I'm not too concerned about the numbers on this one, but you know the distance is here, the time is here, and you should get a, this is the worst video ever, distance graph that's a curve. But the reason I wanted to do this one is because when I grade this, I'm looking for your Mustang one. See, the Mustang one has a higher acceleration. And so the acceleration graph for this one should look slightly different than the one for the MGB. So, same thing for the velocity graph. The velocity graph for the Mustang should look a little different than the MGB. Same for the distance. It should look a little bit different, and that's what I want to see. I want to know that you can tell the difference between the two. Okay? I believe that's it for these two worksheets. Don't forget, you're going to have a test in a couple days when I get back, and here is the study guide. I believe there are also lots of things online that'll help you out as well. But yeah, I say good luck, and make sure you do this. If you have questions, you will be able to ask them when I get back, but make sure you do it and just use a highlighter or something to write down where you have questions so you can ask them when I get back. Okay? I wish you good luck, and don't torture the sub.